Hello, Mr. LIAO. A truss is a triangulated system of components connected in a way to only allow an incurred axial force, and an axial force is the force which is incurred upon the supporting vertical component upon its axes. These components are considered two force components, as the forces are only applied at either end of the component, resulting in either a compression or tension force which is strong as it supports the main structure. The truss is an important structural design used to stabilize roofs, bridges, given their ability to efficiently span long distances, and to construct buildings that can withstand shifting weight, wind, and snow, so that they do not collapse. Trusses are an important stabilizer to buildings, preventing collapse due to any environmental stress. The mechanical stress is spread along the axial component of the truss to ensure it doesn't break. Therefore, less stress concentration occurs at the joints or along the rods. Therefore, the structure can even be constructed using relatively small and weak connecting materials. Also, in our world, mechanical advantage occurs when the output force of a mechanism is greater than the initial input force due to the conservation of energy. The same amount of energy is necessary to move or support an object and preserve equilibrium, though the amount of force needed can be changed. In a situation where a truss is used, the net work is zero. However, the work done by gravity is cancelled out by the work done by the force of the truss, which supports itself by components which push against each other. Since work equals force times distance times the angle from which the force is applied, when distances increase, less force needs to be applied against the architecture, which is being supported due to the self-supporting and larger triangle having a force incurred upon it axially. In our first picture, the truss is seen supporting the roof of the building, allowing an extended roof to be constructed, while not succumbing to the work from the force of gravity due to the truss. The truss in this situation has only an axial force incurred upon it and is supporting the roof. In our second picture, the truss is seen supporting the roof of the building, allowing an extended roof to be constructed, while not succumbing to the work from the force of gravity due to the truss. In this situation, the truss has a diagonal component which has an axial force incurred upon it from a supporting member, which then supports the extended roof. In our third picture, the truss supporting the bridge's handles from moving horizontally off the bridge if a person leans on it. The truss allows a stronger normal force to be incurred if a person leans upon the bridge, allowing for a more stable supporting structure for those who choose to use the railing as a support.